I'm Laura, and I'm going to show you two chemical pattern packages. I chose two instead of one because they're kind of simple and they do some similar stuff, so you can choose the one you like best. The first is Molmass, and it's a Python library that can help you to calculate the molecular mass, the mass distribution spectrum, and a lot of other things. Here is the description as it is on the website. And the calculations are based on the isotopic composition of the elements, so it's good because they gave you a lot of like decimals, not like only the integer value. And for the example, I chose the aminophenol, that is a molecule used in the film industry, like for revealing photographies, black and white photographies. And so I put its formula as the example, and here are some functions I used. Is the mass, let me give you the regular mass with 6 decimals. The nominal mass is like a way that people chose to use only integers, like you choose the most common isotope of each element and makes the calculation according to that, instead of having the average of all the isotopes like the regular mass. Here is the number of atoms and the charge. In its case it's 0 because it's not an ion. There's also you can also print the data frame of the composition of the molecule you wrote. So here is the data frame as it appears on the console, and you can see that there are many information in it. And here is that it shows in the after it prints the code. Like it's how I printed it. So you can see like the elements, how many of each, the relative mass, and the fraction, like how much of the molar mass is from that element. There's another class called elements, and you can choose an element. So I put as an input 94, and I saw the atom symbol that it was Pu, the name that is plutonium, the atom number that it's obviously 94, so it's a little bit redundant, but I could have wrote the symbol or the name where I wrote the number. So the number function would be U2. Please, U2. I don't know how to say U2 in English. Also the description that it gives like a big test. It's very interesting to read. So the plutonium is a dense silver radioactive metallic transuranic element. It belongs to the actinides family, that is the one in the bottom of the periodic table, like the ones that it's off the table normally. It has 13 isotopes that are known, and it's very important to nuclear weapons and reactors, and it was discovered in 1940. We also saw the atom, the electrical configuration of it. So here it gives like the last ones only, like the most the outsider ones, but you can also have the full description, and it shows like that, like it's a dictionary. There's also Mendeleev, that's the name from the creator of the periodic table. There are two ways to install it. The second one is directly from the Git of the creator, so it updates more often. So here we can import the elements, like only the ones we want to use, like I did there. I spelled my own name, but you can spell like whatever you want, or just choose a single element. So we saw like we imported LA, and we saw the name, that is lanthanum, the atomic number of U, it's 92, and the block of Ra, there is radium. They're like the 4 blocks, like SPDF, so it shows you in which one it is, so it's easier for you to find it on the periodic table later. Anyway, you can also import element and use it to call the symbol. Like I wrote the atom, you got an element with the symbol yes, and so he picks this element for me. And I wrote its name, that it's Einsteinium. Also, you can print the electron configuration like this way. And one thing that is very nice that I found that we don't have in the other package is the ionize function. For example, magnesium, its most common ionized state is 2+, so I wrote the 2 there, and he ionizes the element for us, like it removes it. Actually, it's wrong. It's supposed to be 6 there, because I wrote it 3 first and then I changed it because 2 is the most common one. But he takes the less electrons. Here are some of the functions that you can use there. I won't read all of them because it will get boring and confused. So I just show some that like the name is not so easy to understand, like because like atomic number, you know for sure that it's an atomic number, but there are some that are more like confusing names. So at least the ones that I had to search for seeing what it is. Annotations, like if there's any extra annotation in the data of the element. C6 is the dispersion coefficient. There's also the chemical abstract source identifier. It's, I don't know where it is. Oh no, it's the CES, sorry, the last one in the first column. There's like a code for identifying the numbers, like the worldwide convention. The CPK coloring is for those molecular models that we made in school, and it like some elements have specific colors, like hydrogens are white and carbons are black, and like nitrogens and oxygens have their own colors too. So it will show you which color is it in that convention. The discovery location and discovery year, I think they are very nicely. The EC and conf are the electronic conference. Here there's a lot of electronegativity stuff, like the name that it changes is like from the scientists that created the model. So we have like different theories to see electronegativity, like if every changes according to the scale you use. The geochemical class is talks about how often you can find it in the Earth surface. Like it can be a major element, minor, or a trace element. It's only one you have only a little. Goldsmith class is also geochemical stuff. Here are some more. The name origin I think is very cool because it shows you the origin of the name. And VDW stands for van der Waals, like the van der Waals radius according to different theories. There's a class called isotope that you can see more about different isotopes of the atom, because as I told before, like the mass we talk about one atom is normally the mean of all the masses of its isotopes, because it has many, or only some. So here I wrote to print the decay modes of the isotope uranium 235. That is like the radioactive one. The regular one is the 238, and it's decay mode. So he printed like that. Like it doesn't do like a pretty table. It just like prints the data like very straightforward. So it shows the ID, the isotope ID, and the mode of the decay. So A stands for alpha emission, SF is for spontaneous fission, and the like 28 neon, 25 neon, they are for cluster decay. Cluster decay is when you have like a big molecule and it splits, but not like in half. It just like drops a smaller molecule. Like it could be the neon or the magnesium 28. So you can also see more data of the isotopes. You have to like write the element and the mass. So you have to like search the isotope. You can use it in the old code. And I wrote like the abundance. That is 0.72 to the radioactive and like 99 for the regular one. Also the discovery year of both of them. And the half-life. The half-life, for some reason, it doesn't use the same unity. So you have to print the half-life and the half-life unit. So in this case it's million years, but it could also be like billion years. Like billion is the same as the prefix giga. So you would have to convert it if you want to try to make a calculus or something like that. Here are some of the functions of their isotopes in the explanations. There's the half-life I told about before, and there is other things that you can use. Parity, I didn't know the name in English, but it's like as we have the spin number, and it can be positive or negative. So the parity is about that. There's some other information that you may want to know. And that's it. Hope you like it. You can use both of them. Like I think they don't work well like only using them, but they are a great way to retrieving data that you can use in other projects and stuff like that. And that's it.